Hello, it's John Canelopoulos in our center here in Athens, Greece, the Laser Vision Ambulatory Surgery Center. We're in our laser suite. We have the Alcon refractive suite, the FS200 femtosecond laser, and the X500 excimer laser, the Zeiss VisuMax 800. But as I always discuss with patients and colleagues worldwide, the best instrument is the surgeon. And we have here a 37-year-old gentleman who is wearing plano -4 at 110 degrees, and we can see why. There's significant astigmatism, but keep in mind that the astigmatism with the pentacam is 3.6 diopters. So he's wearing plano -4 at 110 degrees. His pentacam is 3.6 diopters with steep axis, flat axis rather, at 117 degrees. Keep that in mind. Now the other eye, he's wearing plano -3 at 175 degrees, and his pentacam in the other eye is just 2 diopters of astigmatism with the rule. So the axis coincides, but less astigmatism than what he's wearing. He's wearing 3, the pentacam is 2.6. To complicate things further, we're going to look at the sitemap maps. The sitemap maps on this gentleman, this is before dilation. So the astigmatism shoots all the way up to 5 diopters at 117 degrees. After dilation with 1 drop of tropicamide, the refraction turns slightly hyperopic here. We're going to +0.5, -5 at 117 degrees. So we have the oxymoron of the patient is wearing -4. Sitemap refraction gives us -5 with +0.5. The pentacam is 3.6. And our refraction is +0.5, -3.5 at 117, and after dilation, +0.5, -4.5 at 115. So what we did here, and it's shown here in this complicated worksheet, is we calculated our cyclospherical equivalent. So our cyclospherical equivalent was -0.175 on the right eye, and we did it inverse TMR. So we dropped the refractive cylinder to mirror the total cornea cylinder and then adjust the sphere. This was a topo-guided treatment. Let's see, Vasu, let's look at the topo-guided treatment with 0 refraction, so we can explain to our friends here what TNT means. So this is a topo-guided ablation, so a contour ablation. I know in the US you cannot go plus 0.13, but the end refraction to achieve the -75 spherical equivalent was -0.06, -3.6 at 117 degrees. So this we could have treated in the US as well with an optical zone of 6 millimeters and a enhanced transition zone to 1.5. In the other eye, we did again reverse TMR, so we reduced the subjective refractive cylinder. That I need to add here is also present on the sitemap measurements even after drop of dilation. So the cylinder recorded with the sitemap after drop of dilation is more than the actual pentacam cylinder, which is 2.6 diopters. So we dropped the cylinder. We again calculated the spherical equivalent, which was -1.37 based on the cycloplegic refraction. And then we went with the Contura treatment of -0.57, -2.6 at 177, and adjusted with TNT. This works out to a -0.25, -2.6 at 177 to achieve the same spherical equivalent of -0.37. Now let's explain a little bit what TNT is. TNT is the expected, and Vasu will help us with the keyboard, the expected myopic shift that this Contura treatment will achieve. And how do we calculate the expected myopic shift? We try and add myopia to the point that C12 will equal C4. So we see here C4 is 0 because myopia is 0. But C12 let's go back and look at the C12. C12 is 0.15. So we're gonna start adding arbitrary myopia to the treatment, and this will calculate for us the myopic shift that this topography guided fix will create. Remember, we started with 0 myopia, 0 astigmatism, so this is just the topography guided recentering of the cornea curvature to the vertex of the patient. So we found that the magic number here is, we know it because we worked on it, so you go step by step, was minus 0.11, because when we put minus 0.11 and we look at the Zernike polynomials, then our C12, which is of course the same, 0.15 equals, or best possible C4, which is 0.14. So we need to add this to the refraction that we're going to treat, otherwise we're going to have a slight hyperopic shift, actually a slight myopic shift. So this is what TNT is, topography neutralization treatment. I know it sounds complicated, but when you do a topography guided treatment, you need to take that into account. So what we did here was broke a lot of protocols. We put aside the site map measurements because they measured way too much astigmatism than the one present in the cornea. And of course, the argument here is, what is the real astigmatism of the eye? Is it the cornea astigmatism? Is it some other element in the eye that adds astigmatism? I've argued for many years that the extra astigmatism is just accommodative astigmatism, that we're not able to break with one drop of tropicamide. So time over time, and for almost a decade now since we introduced the concept of TNT, we've proven that if you go with the confirmed total cornea astigmatism and you adjust for spherical equivalent, that is the best treatment. So we actually went TMR here. We did reverse TMR, so we reduced the cylinder that came out from the subjective refraction, the site map refraction, to match the cylinder of the total cylinder of the pentacam, both in the right and the left eye, and aim for a sphere that gave us the same spherical equivalent than the one in our cycloplanar refraction. I know it sounds complicated. We'll come back with the results in a week's time. This is John Kanellopoulos from our center here in Athens, Greece, Laser Vision Ambulatory Surgery Center, clinical professor of ophthalmology at NYU Medical School in New York City, New York. By the way, we're going to have a whole hour-and-a-half course at this coming ECRS in Copenhagen. It's going to be Monday, September the 15th. I expect you connoisseurs and novices to be there so we can work at some example cases and how the ultimate refractive instrument is not all the nicety that we're seeing here, but it's right here. It's the thought process, is putting logic, physics, and understanding how we can manipulate or better correct the refractive error the best possible. Thanks very much for your attention. Signing out.